Now we look at integration by parts. Integration by parts is also one of the important aspects of integration. It's very, very important. We apply integration by parts when solving or integrating so many functions. Suppose f of x and g of x are functions. And they are both differentiable. If f of x and g of x are functions and they are both differentiable, then the integral of f of x, g prime of x, g prime here means we have differentiated g is equal to f of x, g of x minus the integral g of x, f prime of x dx. Now, f of x, g prime of x is also dx. This is nothing but the formula. This is the formula for integration by parts. You can use this formula to integrate functions that require integration by parts. Now, we are going to prove this formula. You know, integration by parts is just a reverse process of product rule. You know, product rule of differentiation. Now, for instance, let f of x, g of x equal to y. That is the product of f of x and g of x equal to y. Now, if you want to integrate this function, if you want to differentiate this function, you have y equal to f of x, g of x. This can be written like this. The same thing. Now, you have dy or the x. You are differentiating with respect to x. That is why we have dy or the x. Now, this is product rule. So, product rule tells us that if we are differentiating two functions, you differentiate the other one, keep the other one constant, add the results, and differentiate the other one, keep the other one constant. So, in this case, we have two functions f of x and g of x. So, we'll keep f of x constant, differentiate g of x. You have f of x times g prime of x. Now, the next step is we'll keep g of x constant and then differentiate this plus f prime of x times g of x. Now, this is the result. We said we kept this one constant, we differentiated this is the result. Keep this one constant, differentiate this is the result. So from here, if you want to make dy the subject of the formula, you will cross multiply and you have dy to be f of x, g prime of x plus f prime of x, g of x. Then everything in bracket dx. As you cross multiply, dx multiplied by the whole of this function. So now, if I want to get my y back, I have to integrate this. So integrate, you have dy equal to the integral of this f of x g prime of x plus f prime of x g of x dx. Now we know that if we integrate dy, what's the result? You have y equal to the integral of this. Now from here, we know from the rules of integration that if I integrating two functions and you are adding them, you open the bracket with the integral. So if you open the bracket with the integral, you have the integral of f of x g prime of x dx plus the integral of f prime of x g of x in brackets dx. You open the bracket with the integral for this function and for this function, and this is what you have. Now let's call this one equation 1. But from the given problem, we have y equal to f of x g of x. Now if this is our asterisk, now say using equation asterisk in 1, we have, that is where you see y, look at y is f of x g of x, where you see y in equation 2, now replace with f of x g of x. Can you see? It's okay. Now this implies f of x g of x to be the integral of f of x g prime of x dx plus the integral f prime of x g of x dx. Now this is what you have. Now we'll now make f of x g prime of x dx the subject of the formula. This implies if you move this to this side, you have f of x g of x minus the integral of f prime of x g of x dx to be equal to this, the integral of f of x g prime of x dx. Now look at what you have now. So this can be written as the integral of f of x g prime of x dx to be f of x g of x minus the integral f prime of x g of x dx. Now, this is what you have. We know that multiplication is commutative. From the problem we have f of x g prime of x dx equal to f of x g of x f prime. But here we are having f prime of x g of x. Multiplication is commutative. It is same thing. So we now say therefore the integral of f of x g prime of x dx is equal to f of x g of x minus the integral of g of x f prime of x dx. Now we have shown that this is equal to this. Now we have proved this. Now if f of x is equal to u and g of x is equal to v. If you let f of x to be u and g of x to be v, can you see? Then f prime of x will be u prime. Can you see? Be u prime. And g prime of x will be equal to v prime. If you differentiate this, you have this. So now say this in class, what we have here is we'll now use this in this equation. So if you replace f of x with u, now have the integral of u, g prime of x, g prime of x is v prime. So now have v prime dx. With the x distance, your f of x is u, you have u, and g of x is v, you have v, minus the and f prime of x is u prime, then your dx stands. Now, this formula can be reduced to this form. And this is what we shall be using in solving problems that involve integration by parts.